Hi everyone, my name is Maren Spolum. I'm a researcher and lab manager here in SAES studying food access and food insecurity across Michigan using an environmental justice frame. So true confessions. Prior to the invitation to introduce the next speaker, I had never really given much thought to fish. And to be honest, that fish actually pee. and I can tell by the looks on like 98% of the audience faces right now that I'm not alone. So I'm not here to call you all out, but rather to say that collectively I feel like we're all going to learn a lot in the next 5 minutes in this talk titled Fish Pee, an Asset for Improving Coastal Food Sustainability. So let's welcome newly minted assistant professor from the Department of Ecology and Evolutionary Biology, whose favorite food is either tamales or scallops, Jake Allgeier. Welcome, Jake.
Thank you very much. I'm not going to describe how they pee today, so you're going to miss out on that. Oh, it went the wrong way too. But I am going to talk about the potential importance of their pee. So we're starting now. So there's roughly 1/3 of the world lives within 100 kilometers of a marine coastline. Most of these people live in tropical regions, and most live in impoverished conditions, and these numbers are expected to increase. So roughly by 2050, we're expecting close to 5 billion people living along coastlines. So this motivates a question that is central to my research, and it's essentially what mechanisms can be put in place to sustain food security for all of these people. One of the critical challenges associated with this question is the fact that most of the habitats within these coastal regions are highly degraded, particularly in the tropics, where coral reefs, seagrass beds, and mangroves are essential for the food security for literally millions of people throughout the world, but they're among the most impaired ecosystems globally. So a key proposed mechanism for maintaining this security is enhancing the number of marine reserves we have throughout the world. And the idea here is we just simply protect a chunk of the ocean, and that can help maintain the food security that these regions and ecosystems provide. This slide is an old one, so I'll go here. So about 4 years ago, I was invited down to Haiti to help provide a scientific recommendation to delineate the first marine protected area in this country. And we were working closely with the Nature Conservancy and the United Nations based on, for this large-scale project, the Caribbean Challenge, which is the goal is to create 20% of the coastal area in the Caribbean, protect 20% of the coastal area in the Caribbean. And this resulted in the delineation of a marine protected area surrounding this small island in the southern part of the country called Île aux Vaches, where I do most of my research. The sort of irony of this is that this island also houses or is home to thousands of people who rely directly on the resources provided by the marine environment. And so it's hard to go into these areas and ask these people to not fish or utilize these resources when they rely directly on these resources to feed their family and themselves. So my previous research has shown that fish pee is among the largest source of nutrients to coastal ecosystems in the tropics. And essentially providing, excreting fish through excreting nutrients are providing the fertilizers that are making these ecosystems highly productive, among the most productive ecosystems on the planet. And so our idea is to essentially utilize this sustainable resource as a tool. The idea is relatively simple. We construct artificial reefs in seagrass beds, providing a three-dimensional structure in a relatively two-dimensional space. Fish aggregate around these reefs and excrete nutrients to the local environment. This excretion of nutrients, we've shown, can enhance the production of the seagrass beds around these artificial reefs by up to 400%. And this sets in motion a ecological feedback whereby the enhanced production provides more food resources and habitat, which promotes increase in invertebrate densities, which potentially, we haven't quantified this yet exactly, potentially enhances the production of fish locally around these artificial reefs. And we've done this extensively throughout the Bahamas as well as Haiti. We have nearly 70 artificial reefs in place. And it's effective. Slow too. So the goal is then to scale this up. So instead of having single reefs isolated in areas around a given region, the goal is to build reefs in clusters. And the idea is that working with local fishers, we can promote the idea of fishing some clusters and actively not fishing other clusters. And the goal would be that the areas that are fished can then essentially fuel fish to other areas that are, or areas that are unfished can essentially fuel areas that are fished by fishers, promoting a net increase in food security. So in that case, instead of having a broad area that you protect and you ask people not to fish whatsoever, we can install these clusters of reefs throughout in specific spots, specifically in seagrass beds, where fishers typically don't fish very much anyhow, potentially increasing the net production of fish throughout the local region. And so this is an ongoing project, and we're moving forward with this right now. We go into these communities, we work on educational outreach by talking with the communities, by working with the school children directly, and we work directly with the fishers as well to build these reefs and to engender local support for these ideas. And that's it. Did I make it on time?
I drank a lot of sustainable coffee before I